I'm Ron Boy from Weasley. I'm Hermione Granger. Chasers Spinner's enemies of Dad Black.
You betrayed my parents. You're the reason they're dead. He's mad. Voldemort's mad.
She killed you. You know the spell, Harry. I must be the one to kill him, Harry.
After the death of Dumbledore, the Wizarding world is in turmoil as Voldemort begins to take over. Voldemort is on a mission for the Deathly Hallows, 3 magical items that can make any wizard the master of death. Before Dumbledore is murdered, he teaches Harry of the Horcruxes. The Horcruxes are 7 items Voldemort has split his soul into. If Harry destroys all the Horcruxes, Voldemort will die. With the help of Ron and Hermione, he has found and destroyed most, but one still remains, Nagini, Voldemort's snake that never leaves his side. Harry returns to Hogwarts, Voldemort follows him, and a war ensues. But as more people are dying, Harry feels bad, and Voldemort announces that if Harry goes to the Forbidden Forest, Voldemort will spare his friends. Voldemort kills Harry, and he ends up in an area between life and death, at King's Cross Station, specifically Platform 9 3/4, with Dumbledore. Dumbledore explains that since Voldemort used some of Harry's blood to regain power, Harry is a Horcrux. Harry returns to Hogwarts, Neville Longbottom kills Nagini, and Harry kills Voldemort, making him one of the dead.
In this scene, the dragon escapes from the Wizarding Bank. With Harry, Hermione, and Ron on its back, the dragon crashes through floors, windows, and ceilings, and eventually gets to the top of the roof. When the dragon reaches the roof, it sits there for about 10 seconds to catch its breath. We then asked ourselves the question, is it possible for an object of this size to sit on top of a roof without the roof collapsing? The first step to answering our question was finding out which formula to use. We decided on using a force equation. So we looked at one of the forces acting on the dragon, which was the force of gravity, or weight force. The equation for the force of gravity is mass times gravity. After deciding which equation to use, we then had to find the mass of the dragon. Comparing its body shape and dimensions to the size of a prehistoric velociraptor was how we discovered the mass of the dragon. Therefore, the mass of the dragon had to be at least 10 tons, or 9,072 kilograms. Then we substituted numbers into the force of gravity equation. Fg equals 9,072 kilograms times 9.81 meters per second squared, which equals 88,996 newtons. With this information, finding how much mass a roof could hold would answer our question. An average roof can hold about 20 pounds per square feet, which is equal to 9 kilograms per square meter. The bank was the size of a large commercial bank, which is about 3,500 square feet, or 325 square meters. Therefore, to figure out how many kilograms the roof could support, we had to multiply 9 kilograms per square meter by 325 square meters, which equaled 2,925 kilograms. Therefore, due to the fact that the dragon's mass was 9,072 kilograms, there was no possible way for that roof to support that big of a mass. So, this was an example of bad physics. The second example of bad physics throughout the movie is when the wizards fly on their broomsticks. Flight has 4 forces acting on it: weight, drag, thrust, and lift. Birds can easily fly due to the fact that they have wings and weigh much less than humans. However, we all know that for humans, flying is impossible on Earth due to the fact of the force of gravity. Gravity is the force that attracts a body towards the center of the Earth. Also, humans are much too heavy and cannot produce enough energy to fly on our own. To prove that a human flying is impossible, we use the equation for lift. The equation for lift is L equals half PCAV squared, where L is lift force, P is the density of air, C is the lift coefficient, A is surface area, and V is velocity. To maintain flight, the force of lift must equal the force of gravity. To create lift, we would have to generate thrust. To keep moving, we need to overcome the resistance of air or drag. So we plug the numbers into the lift formula. equals half times 1.25 kilograms per meter cubed times 1.2 times 1.5 square meters times 5 meters per second squared. So L equals 30 newtons. Therefore, Harry would have had to be moving at 6.5 meters per second to achieve 30 newtons of lift. From our knowledge of flight, the given data proved that flying is not feasible for humans. Therefore, this demonstrated a bad example of physics.
The first example of good physics in Harry Potter was the roller coaster scene known as the ride to Bellatrix's Vault. This is an example of good physics because of circular motion and centripetal acceleration. The conversion of potential energy to kinetic energy is what drives the roller coaster. All of the kinetic energy you need for the ride is present once the roller coaster descends from the first hill. The centripetal force points towards the center of the circle, while the rider experiences a force which feels as if they are being pushed backwards. A roller coaster car traveling in tight loops, as in Harry Potter, will experience a greater acceleration than those in a wider loop. To calculate the centripetal acceleration, you would use the equation acceleration equals velocity squared divided by the radius of the circular path. We first found the velocity. We determined that the distance of the roller coaster was about 1,609.34 meters, and the time they traveled that distance was about 49 seconds. We then found that the tallest character riding in the roller coaster was 5 feet 8 inches, meaning that the radius of the loop had to be at least 3 feet, which would be converted into 0.91 meters. Using the data collected, we found that the centripetal acceleration was 1,185.13 meters per second squared. The second example of good physics in this movie was the scene in which Professor McGonagall ordered the stone soldiers to jump down from their positions on the top of Hogwarts Castle. While it may be unrealistic for an object made out of stone to get up and walk around, the reaction the free-falling bodies had would be considered accurate in the science of physics. The force of gravity pulled the large objects downward to the ground. The type of physics that applies is Newton's first law of motion. The law states an object at rest will stay at rest, and an object in motion will stay in motion at a constant velocity unless acted upon by an outside force. This law remained true throughout the scene. The stone soldiers remained airborne until they reached the ground. When they hit the ground, the soldiers came to a complete stop. Secondly, the impulse momentum theorem could be applied. Using the equation force multiplied by time is equal to the mass of the object multiplied by the change in velocity. In words, this equation states the impulse is equal to the change in momentum. We estimated that the mass of the large stone soldier would be equal to that of a pickup truck. The average mass of a pickup truck is equal to about 3 tons, converted to 2,700 kilograms. We would then use the equation force equals mass times acceleration to determine the force. Using 9.8 meters per second squared for the acceleration, the force would be 26,460 newtons. It was then taken into account that the soldiers were in free fall for about 3 seconds. The product of the time and force would be 79,380 newtons per second. We then found the height of Hogwarts Castle, which was about 88.2 meters tall, meaning the soldiers traveled that distance. The velocity of each soldier was about 29.4 meters per second, which would then be multiplied by the mass and receive a product of 79,380 kilograms per meter per second downward, equal to the previously calculated impulse.